Hi students, MCQ number 25. 16 gram of oxygen, 14 gram of nitrogen and 11 gram of carbon dioxide are mixed in an enclosure of volume 5 liter and temperature 27 degrees Celsius. The pressure exerted by the mixture has to be determined. Now first of all, from the ideal gas equation, PV is equal to mu RT, or this also can be written as small n times RT. You can either use the symbol mu or n for the number of moles. Okay, for the number of moles, either of these two symbols can be used. Okay, now first for the first gas, that is oxygen. For oxygen, the molecular, that is the molar mass. Oxygen is diatomic, is it not? 8 over 16. 16 into 2 is 32 gram. So for oxygen, M1 is equal to what? 32 gram. But here only 16 gram of oxygen. This is for 1 mole. Okay, this corresponds to what? 1 mole. So the number of moles, 16 gram corresponds to what? Half mole. Therefore, the number of moles N1 is equal to 1 by 2, that is equal to 0.5. So the number of moles in 32 gram is equal to 1 for oxygen, but given mass is what? Only 60 gram. That corresponds to only half mole. Are you understanding this first? Okay. Similarly, for the next gas is what? For nitrogen. So for nitrogen, which is also diatomic, the molar mass, nitrogen is what? Nitrogen 714. So diatomic means 14 into 2 is 28 gram. So this is equal to what? 28 gram. And this is the mass corresponding to 1 mole. But here how much gram is given? Only 14. Half of 28. So the number of moles, therefore the number of moles N2 for nitrogen must be equal to 1 by 2. So this also is equal to 0.5, half. Okay. Similarly, for the third gas, that is carbon dioxide. So for carbon dioxide, 1 carbon atom and 2 oxygen atoms are combined. Is it not? So its molar mass M3 must be equal to what? I am going to add carbon 6, 12. Carbon is 12 gram. And diatomic oxygen is what? 32. 32 plus 12 is how much? 44 gram. So this is 44 gram, 1 mole of carbon dioxide. But given mass is what? 11 gram. 11 fours are 44, is it not? So out of 44, this is only 1/4. So the number of moles, therefore the number of moles in 11 gram of carbon dioxide, that is N3 must be equal to what? 1 by 4. So that is 0.25. Are you all understanding up to this? Good. Number of moles present in 16 gram of oxygen is 0.5. Similarly, 14 gram of nitrogen corresponds to 0.5 number of moles, and in 11 gram of carbon dioxide corresponds to 0.25 moles. So this equation now, PV is equal to mu RT or nRT. I am going to rewrite. So from this, P is equal to RT by V into number of moles. RT by V into number of moles. So suppose if it is P1, okay, P1 is equal to N1 into RT by V, and P2, the pressure exerted by the first gas is P1, the second gas is P2, that is its number of moles into RT by V, because all the three gases now are maintained at the same volume and temperature. R is also the same for all the three gases. So the pressure exerted by the third gas must be equal to what? N3 into RT by V. So total pressure exerted by all the three gases, the total pressure must be what? P is equal to P1 plus P2 plus P3. So the common factors for all the three is what? RT by V. Only N1, N2 and N3 we have to add, is it not? So this must be equal to N1 plus N2 plus N3 into RT by V. Okay. Now this is N1 and N2 and N3 already we have written here. Now R is the value of gas constant is what? 8.31 joule per mole per Kelvin. Temperature is 27 degrees Celsius. So this is equal to 27 plus 273 Kelvin. So this is equal to what? 300 K. And volume V is equal to 5 liter. So liter is converted into meter cube, 10 power minus 3 meter cube. Now I am going to substitute the values of RT and V in the previous equation. Therefore, what must be the total pressure must be equal to N1 plus N2 plus N3. So the number of moles 0.5 plus 0.5 plus 0.25 into RT by V. So this is 8.31 into 300 divided by volume is 5 into 10 power minus 3. So now you see this is 0.5 plus 0.5 is 1. 1 plus 0.25 is 1.25 into here 831 is there, is it not? 8.31. Here 300 I will convert this as 3 into 100. So I can write this as 831 into 3 whole divided by 5 into 10 power minus 3. This 10 power minus 3 also, if it is coming up, I can write this as 10 power plus 3. So now let us find out this calculation. So 1.25 into 3 into 831 divided by 5. So this is divided by 5, that is equal to 623. 623 into this 10 power minus 3 is coming up as a 10 power plus 3. Okay. Now after 6 there are 2 decimal digits. So I can also write this as what? This also is equal to 6.23 into 10 to the power of 5. Since it is pressure, the unit is Newton per meter square. So what are all the options? 5 into 10 power 5. So this is 6 into 10 power 5. This is 9 into 10. So almost it is nearly equal to 6 into 10 power 5. So the option C must be the correct answer. Sometimes our answer will be 6.023. Like that, some close to the answer, some numbers will come. So which is the most appropriate answer only we are going to find out. So you cannot say none of the above here. So option C must be the correct answer. Understand? So option C is the most appropriate answer. Okay. Though the problem is very lengthy, but it is very easy only. The concept, if you have understood how to find the number of moles here only, you should be very cautious. I hope you must have understood this well. Fine.